My viewers have been asking me to make a video demonstrating how to unit test a React component that uses the React Router 7's await function when it's used with React's Suspense out-of-the-box component. Now, to be clear, I'm referring to React's Router's await function, not the JavaScript async await paradigm, which is just syntactic sugar syntax for promises. The React Router's await function is designed to be used inside of a React Suspense component, as indicated here by the React Router 7 documentation. The React Router await function does return the value of a JavaScript promise, probably why it's called await. In order to be fair to viewers who just happen to click on this video without an in-depth knowledge of the React Router's library, various modes, including modes that allow you to fetch data without using the React useEffect hook, I need to give a brief synopsis of the latest version of React Router. For those of you who are anxious to get to the unit testing part, look at the video's timeline that I have provided for you and skip to that section of the video. I will also provide a GitHub repo for the completed project, including unit testing for this tutorial. I would appreciate it if you would give that repo a star. React Router is more than just a views router for single-page apps. Starting as early as version 6.4, React Router offered the ability to load data, which actually makes a lot of sense if you think about it in the context of UI rendering, programmatic flow, side effects, and mutations. The React Router's data APIs handle data fetching for us, which avoid race conditions, double fetching, and other issues when we use React useEffect hook to fetch data. I'm not saying that we shouldn't use the useEffect hook. I'm saying that we should not use the useEffect hook for fetching data. The creators of React Router refer to these additional capabilities as multi-strategy routing for React. You can load data in framework mode as well as data mode. However, I will focus on the data mode and unit testing loading data in data mode per the request from my viewers. Conceptually, React Router data loading is pretty straightforward. First, you create an async loader function to fetch data from an API. And of course, JavaScript fetching returns a promise, so we have to use an await here. There should be an async keyword in this function. I will make a pull request to fix the docs at a later time. This loader function will be parsed to the root array of objects for routing purposes, which is a very common pattern in pretty much all of the single page apps, libraries, and frameworks when it comes to routing views. The next essential function for data loading is the function where we incorporate the useLoaderData hook provided by React Router, which we can use to access and manipulate the data that is being fetched by the loader function above. One caveat is that when we import from React Router 7, make sure that we import from React Router, not React Router DOM, because in version 7, the library has been unified. Some of the AI tools that might still import from React Router DOM AI tools suck at configuration, although that might change in the near future. Anyhow, this book function will be parsed to the app's routing array of objects as well. We will be creating our own app utilizing these two concepts here, and then we will focus our unit testing on these two functions, as well as others, but primarily these two functions for our unit testing with Vitest. We will be creating our own application based on the aforementioned data loading concepts in React Router 7. If you've watched my previous tutorials, you know that I'm quite fond of the dummy JSON free API, which offers the complete CRUD routes for testing your front-end code. In this case, in this application, I am requesting the first 10 products with title of the products and a thumbnail pic. React Router 7 is capable of all of the CRUD routes: get, post, update, delete, patch, etc. However, in this tutorial, I will be focusing on the get route as well as the post route, and we'll be unit testing the get for loading data. The data that you see before you is being fetched via React Router. I am not using useEffect or 10-stack query or anything like that. Again, we are fetching 10 items initially. I've chosen this view as the initial view. It's up to the developer as to which view they want to have loaded initially. The home route consists of only these two buttons. We can post data using React Router 7 as well. In this case, I am posting data to the dummy JSON API, which will accept a post request and will return response data. As you can see here, we're getting a 201, and look at the response object. I've already made 3 different videos for how to set up Vite with React, Vite with React and Vitest, Vite with React error boundary and lazy loading, as well as Suspense with unit testing, as well as just basic Vitest setup with Vite. So in this video, I'm not going to go through all of that. We're just going to go straight to the code. We will start with a bare bones app.tsx TypeScript component file. I will be handling all of the data loading functionality and routing logic in here, simply because it's easier to demonstrate, so I don't have to switch back and forth. In a real application, certainly you will want it in its own directories for ease of scaling later on. Let's have a look at what we're importing starting on line number 2. Suspense from React, we already know what that is. I mentioned await earlier in the documentation. This is used in React Router's data API to handle asynchronous loading in routes. Now, with respect to createMemoryRouter, you might be wondering why I'm not using createBrowserRouter. Well, server-side rendering for React app is sort of like the rage these days. So let's just presume that we can repurpose this application for server-side rendering. Obviously, it will work on the browser side as well. If I were to start out using the createBrowserRouter, and then you follow that pattern, you follow my teachings, and then one day your boss asks you to change it to a server-side render application, then you're gonna have to refactor a lot of logic. This way, we can start it out as sort of like a quasi um, server-side rendered application that can certainly be rendered on the client side. If later down the road you want to switch this client, create memory router to create browser router, the logic is very simple. It's basically just relocating this root array of objects. The type root object is a TypeScript type that represents a single root in a root's configuration, like on line 23 here. It has properties like path, element, and children that we use to structure out our root for the app. The root provider is a component used at the root of our application to provide the router instance for the rest of the rack component tree. It'll be used something like this. Of course, this will error out because I don't have this coded out yet. useLoaderData, we went over that briefly in the documentation. Is a hook that lets you access data loaded by the root loader function, which would be the product's loader function here on line 15. And then finally, useNavigate is a common functionality within pretty much all of the routing libraries for pretty much all the SPA libraries and framework. And this library is used to navigate between routes as well as between views. And once again, please be sure that you do not import from React Router DOM. Make sure that you only import from React Router in React Router version 7. And of course, I have the loader function, the products page component. I call it page because it will have navigational functionality within that component. Uh, as you notice here, I am handling errors outside of the product, and I'll get into that here in a minute. The roots object, of course, this array will handle the array of objects for each individual root, and the app, of course, to tie it all together. Taking a quick look at the await documentation, we see that await has a few props. Now, resolve and children we will definitely implement, but if you notice earlier, I mentioned that I will handle the error issue outside of this function. If we were to look at the source code for that function or component, we see that the error element is optional. And so by making this function separate from this function, it's easier to unit test. Let's code out the loader function because that's the easiest. This is just basic JavaScript. In this case, it's TypeScript. So it will have a type of promise, and what I'm bringing out from the API would be the ID, of course, be a number, a title, which is string, a thumbnail pic, which is a string link for the image. And by default, dummy JSON will return 30 product. I only want 10, so I'm setting the query string param to just 10. And here in Postman, we can see what the API is returning us in the form of a JSON, of course, the ID, the title, and the thumbnail, which is a string for the path of the thumbnail. And I will pass the string into the image source in our code. And I created this type up here on starting on line 14 only because I will be using this product response over again. So I don't have to retype this whole shebang here. So with respect to the products function, the reason why there is an export keyword here is because I will be exporting this to the app.tsx file for unit testing. Now, normally I do TDD, test-driven development, but I'm making this video for my subscribers and my viewers who is requesting specifically for a unit testing Vitest with React Router video. And so I will be doing that part in one go. So that's why I'm taking care of the code file first. So then I'm bringing in navigate because I want to be able to, from the products view, I want to be able to navigate to the home view and the at product view. So I want to be able to reroute my application. And then of course, I've mentioned this several times already, the use data is using the data that the product loader up here is bringing back from the API, and I'll show you how to implement all of this in a bit here. But this returns a promise, so therefore this will have a generic of a promise. Okay, so that's why I'm calling it data promise. Let's take care of the navigation next for this component. We'll navigate via a button. Um, the on-click event will fire off the navigation that we brought in up here. It's very simple. The pattern is very similar to any other frameworks or libraries. We do not have a home component yet, but that should be very simple to implement. I'll do that in a second. And then this add products uh, navigator will take us to the view where we add the product, which I demonstrated earlier. And then we'll add our suspense and our await logic down here. So here we will apply the React suspense with the fallback. In this case, the fallback is very simple. I have a video which covers thoroughly how to implement a suspense and fallback. This is where we use our React Router 7 await function or component. Now, this function, the await function, takes a resolver. And the resolver here is the data that we're bringing back from the API. What is that data? So once again, that data is the first 10 records. And I'm bringing back only the ID, title, and thumbnail. Now, this feature is exclusive to dummy JSON so that we do not have to bring back stuff that we don't need from the API for better bandwidth consumption, right? Certainly, in your own company, the backend team can implement something like this as well. So once again, we will pass the data promise that was declared up here, and it uh, bringing back the data from the API. So at this point, we have the records coming back, the records of products coming back from the API. And once we bring the data back, we can loop through it. And of course, the return data will have this product response type. As you can see here, I'm using this type in multiple locations. So that's why I created this type of product response up here. And then of course, this part here is just standard React, right? Um, I'm using the ID as the list item key because I'm confident that the ID is consistent in the API, it doesn't changes, and is in numerical order. And then of course I will be using the thumbnail, so I'm providing the that string as the source for my image, thumbnail image. This is for the uh, vision impaired, of course, as alt tag, and then the title. Okay, standard React stuff. So now I have my suspense, my await with a resolver, the children, and then a very basic products error handling function here. Okay, now let's put this together. So the way that we let the router know our products error, products component, as well as our products loaders, is that we declare an array of roots which will have different objects with different roots in it. The first one is reserved for the home, which is just a basic slash forward slash and nothing else. I have not created the home component, but that should be easy to create. If you recall from the demonstration and the UI, the home component consists of a couple of buttons, one to get to the products page and one to get to the add products page. So for the path in our routing, it would be just / products. That would be in the form of a string. Now, the element is referring to the component itself. Okay. And then the loader, what do you suppose that one is? Right? We have something called the products loader up here. Okay. And so we will pass that in like so. Okay. And then for our errors element, right? Errors element, right? And so we will pass in the error product errors component. So off screen, I've added the home component, which is very simple. We're familiar with this pattern now. We bring in use navigate, and then we navigate to the route that we want. Now we have product. We do not have add product yet, but we will add that later. So for now, and of course I've added the home path here. So for now, why don't we wire up app, and then we can at least see the loading of the data in the browser without the styles. Before we code out the app component, I want to talk about this type that I created, which would be used as the type for the app component. Initial entries is the ability to specify what route to set the application to, or what initial view we want to have. It's a string array type because it'll look something like this. And if you wanted to start out on the landing page, on the home page, you simply would have /. And then the routes will be the routes that we define here, or a custom route. Why do we want a custom route? Remember earlier I mentioned that we are using the createMemoryRouter instead of the browser router. We may have custom routes if we want to test or customize the app's routing outside of the component, such as in unit test or like in Storybook setup or something like that. And this is how I implement this type that I created for the signature of the app function. For initial entries, I want it to be the /products view, which is the view containing the 10 products that I brought back from the API with a thumbnail pic and the title for each product. And then for the routes, I want this to be a custom placeholder in the future if I wanted to implement testing from outside the component, or to test some sort of system design like Storybook. I'm referring to front-end systems like Storybook, something else like that. I'm commenting out line 110 because I wanted you to see what the root provider looks like when we return it. And as you can see here, the root provider component takes router as the prop, and we have to pass in something, right? We have to pass in our specific routes. So therefore, on line 110, we declare a router, and this is where we select what type of router to use. And as I mentioned before, we're using the createMemoryRouter. Okay, so then here, if there are no custom routes, then we're going to go ahead and use the routes that we define here. Okay, again, I'm still missing the add product, but that'll come in a bit. And then initial entries. Now, initial entries again is optional, but it would make sense for us for this to land into products. Obviously, you could have your home component render the products as well. Okay, so now let's test this out in the browser. So when this project is completed, I will add Tailwind CSS version 4 styles to this, but for now I remove all of the styles. You can see here the components do not have class names on there, because if I were to add class name, the code will get really noisy. And I wanted you to walk away from this learning about React Router and unit testing, not about CSS styles. So this is the initial entry view / product in the browser. As you can see here, we are getting our 10 products back with the thumbnail pic as well as the title for the product. And we have the ability to um, go to the home page, which only renders the to button. Of course, we have not added functionality for adding a product yet. We will do that soon. So there's one thing I want to point out at this point. If you recall earlier, we chose to create memory router. And so um, you will get a warning in the browser that says no hydrate fallback element provided to render during initial hydration. This is a very common problem with React Router 7 when we're using the data mode. Okay, and there's a simple fix for this because createMemoryRouter, like I said earlier, is designed for server-side rendering with React. Okay, remember, we can do server-side rendering in React with multiple libraries. Next.js is not the only game in town. Okay, this is a very easy fix. I'll show you here in a second. To fix that warning, in our root configuration, we add hydrate fallback to null. Right? Okay, we pass that in as a function. Now the warning is gone, as you can see here. Again, that warning occurs because createMemoryRouter was designed for server-side rendering. If you wish to refactor this code base to browser router, it's a very simple refactor. You just move the routing configuration location. I will go through posting data to the API via React Router relatively quickly because this video is already getting long and I've yet to cover unit testing. Posting data to an API endpoint using React Router v7 essentially required 3 steps. We create a function for the form itself, which, as you can see here, the library is providing us with their own form, and then we present this to the end user to enter their data. We create a function for that. And then we create an action function to extrapolate the form data to submit to the API endpoint. And this is what this hook is for, this use action data hook. And then these two hooks, use navigate and use navigation, you've seen this before. Use navigate is just to navigate between pages programmatically via button click. And then the use navigation hook is to capture the state of the routing state so that we can dynamically render text and what have you based on if we have submitted a form or not, or something similar to that. And then we connect these two functions to the routes configuration in the app.txx file in our case. Now, the useEffect hook and useRef hooks that I've imported here, this is only used to clear the form fields after the form has been submitted. These two hooks has absolutely nothing to do with communication with APIs or mutations. Let's have a look at the postProduct function. So in this action data constant, I'm using the use action data hook to get the ID and title because if you recall, I demonstrated when we post the form successfully, if we post the form successfully to the API, we will render out the text product added the title, and the ID. The ID, of course, is issued by the API endpoint itself if we get a 201, if the posting of the data was successful. And then we also using action data to detect when it's the correct time to clear out the form fields via this useEffect hook and the ref. So that's the only reason why I brought in useEffect. As you can see here, this useEffect, it has nothing to do with API communication or data mutation. It's only used to clear out the form fields. I just want to make that clear, no pun intended. And in terms of the navigation state, I'm using that to determine the text for the button based on the state of the router and where it's at in terms of posting data to the endpoint. And of course, navigate is only used to navigate away from that view via the button click. But certainly the star of this function is the form that is provided to us from React Router v7 itself. And as you can see here, it is very easy to implement. You pass in the method. This again, this is only the ref here is only to clear out the form after it's been successfully submitted. But like I say, it's very easy to implement. Is the pattern is the same for pretty much all the forms, either to React or to native HTML. Super simple. So we figure out the form. Now let's look at the action. The action really is just a regular post request via fetch. Now we do have this request object that has form data in it that we submit to the API endpoint. Again, we're submitting the title and the price, and then the return object would be whether it was successful or not, and the ID that was issued from the endpoint. Nothing out of the ordinary here. You've been doing front-end programming for a little bit. This pattern is recognizable and easy to learn. And then we go back to app.tsx file or whatever your root's configuration is located. Of course, you would have to import those two files, the postProduct component, which is Pascal case, of course, and then the action itself, which is camel case. You have to import that if it doesn't live inside of this file. And the reason why I coded in a different file was because this file was really getting too long. So you add it to the configuration and you're ready to test this out in the browser. We're going to do one more test to make sure that the text on this button is changed when we click on add product. It will be very quick, so you have to pay attention to it. See how that changed? It was very quick with a change based on that use navigation state hook. With regards to unit testing using Vitest, or really any other testing library, per the React Router 7 documentation, trying to test suspense with await from React Router inside of it is sort of a fool's errand. And it's not a stable, productive test. That's why the documentation doesn't give you an example of it. I think the better approach and what's actually recommended by React Router v7 is to test the loaded state. For example, in this case, the products that's being rendered, we want to make sure that renders correctly. And then since we have navigation within our app and error handling, we should test that. So again, just to repeat myself, tests should be focused on the loaded state, which is the products being rendered, the navigation around, and the error handling. And so to that end, that's what I will be focusing my unit test on. Now, it's possible to test the suspense in isolation, and I have a video about that in terms of Vitest, error boundary, and suspense. But when you're trying to load data with the React Router event function, that's not going to be a stable test with React Suspense. Should that change in the future, I'll definitely let you know. A common question that I get asked often is why do we need JS DOM for Vitest? Uh, and the reason for that is because we still need the custom matchers uh, for Vitest from JS DOM. That's why I put this comment here, because I get asked this question so often. I put this comment here so people can reference it. Let's go ahead and import the modules that we need from the testing libraries that we're using, and then from the actual React Router library itself, and then we'll import the components that we'll be testing, and then we will mock. Now, there's multiple ways to do this. I'm doing this statically and explicitly. You can certainly create a dynamic function for this, but for mocking this up, I've basically create a static mockup. And then we're going to create a loader to simulate a delay in fetching. I want to test what I feel like is the most important thing in this application, and that is to make sure that the products get loaded correctly on the initial entry, which effectively is our landing page. So therefore, I've created a root array which simulates our routes configuration, if you recall, in the code file itself, and I'm bringing in createMemoryRouter, which is the router that we're using in our code file, and of course with initial entries of /products, our again our effectively our landing page. Then we're going to render the router provider so we can start issuing expect statements against. By the way, in package.json file, I created a test watcher for you so that you can watch your tests while you're creating the test, or simultaneously creating the test while you're coding. I want to spend a little bit more time to explain line 28 and 29. Now, if you look at line 28, there's an await statement there, and then line 29 does not. And the reason for that is because we're waiting for elements to appear asynchronously in line 28 versus checking for elements that should always be present in line 29. So again, just to explain this thoroughly, because you're going to see this pattern again uh, in our test suite. So await screen find by text for product 1 on line 29 is asynchronous. It waits up to the timeout for product 1 to appear in the DOM. And we use await because the element might not be there immediately due to latency. In this case, it's just a timeout, a fixed timeout. On line 29, screen get by text for product 2 is synchronous. It expects product 2 to already be in the DOM. And if the element is not present, it throws an error immediately. So why do we have both? So in our test, we wait for product 1 to appear, which means that the async loading is done. And then we check synchronously that product 2 is also present, since both products should be rendered together after loading. Okay, I know I'm spending a lot of time on this because I want you to understand this, because you're going to see this pattern again. So we use await find by text for elements that appear after async actions. And then we use get by text for product 2 for elements that should already be present. And then I want to test that the image is there for product 1. Next, I would like to test our error loader, and I do that by simulating a promise.reject. Go ahead and scaffold out your it block. Render the app with the initial entries of /product and then load our test routes here. And then we expect to see that the fail to load products appear within our JS DOM, simulated DOM. Of course, the I is to indicate that this is case insensitive when we're searching for this div here. Next, I want to make sure that the home component renders correctly and that we can navigate to the products view when we are on home. Now, the pattern is similar to what we've used previously, so I'll be going through this relatively quickly. Create our test routes, render the app. Now, these two are relatively easy to understand and pretty much self-explanatory. We are going to simulate a user click of the button to go to the products page. Then we wait a little bit, and then after that, after we navigate to products, we make sure that product 1 is there in the document, in the DOM. Let's make sure the navigation is solid. So once we are at the products view, we want to make sure that we can safely navigate back to the home view. Similar pattern to what we had before. So currently we are on the products view, and we can verify that by making sure that that product 1 is in the DOM since we're on the product view, right? We have not navigated back home yet. Then we're going to do an async click, at least simulate a click on the button to go back to the home view. And then if we safely made it back to the home view, then we expect the home text within the button to be there. Of course, this is save, and as you can see here, the tests are pausing. Okay, so I think I've shown you enough patterns for you to create your own tests, additional tests if you wanted to. Hopefully this was an enjoyable tutorial for you. I hope you got something out of it. There's something here for everyone. If this was beneficial for you, please consider subscribing to my channel. It doesn't cost you anything. If you like the video, please consider giving it a thumbs up. Otherwise, I'll see you next time. Thank you for watching. Bye for now.